Very good morning, all my dear students. So today we are here to study SN1 reaction. You must have studied number of times SN1 reaction, but today here your HSP Baba is going to tell you SN1 reaction in some different way, so that you can think by yourself. Just let me second see to it whether everyone can hear me, can see me. Kids, first of all, let me know that am I audible and visible to all of you? Can you perfectly see me? Just to let me know so that I can start the reaction. Priyanka, hello, very good morning. Buddha Shurya, Leo Messi. Oh, Messi is there. That's really awesome. Messi is there. So kids, today definitely I am going to tell you this SN1 reaction in different styles so that every question, each and every question of any examination, you can do it within fraction of seconds. But first of all, everyone show me some green signal from the chat section. Hey, everyone, I can't see the fire. If you can hear me, can see me, do let me know so that I can start this reaction. This is a flask and this is SN1 reaction. And SN1 reaction 1 means what? I will let you know. I will let you know each and everything in detail. But first of all, yeah, Priyanka, that's really awesome. That this fire is indicating that I'm audible and visible to each and everyone. Leo Messi, Buddha Surya, that Josh is really high. Now, first of all, let me write down the full form of SN1. What is the full form of SN1? Everyone, you must be knowing what is the full form of SN1. 1 means unimolecular. N means nucleophilic. And S means substitution reaction. This to everywhere it's written substitution reaction. Kids, there is nothing in this that unimolecular nucleophilic substitution reaction. You can see this to be written everywhere. But just if you want to understand any reaction, kids, you have to do one thing. You have to apply your brain. If you are the scientist, how you are going to think about it, then it should be very easy. You can make each and everything very simple if you apply your brain. What you do, you always think like the bookish language or whatever the teacher is telling you. I will teach each and everything in the way that you are going to think. So, I welcome to each and everyone to yours Unacademy NEET English channel. I hope that everyone is great and doing good job, fit and fine. Now let's see. Unimolecular nucleophilic substitution reaction, what does it mean? The meaning of unimolecular nucleophilic substitution reaction is that the rate of reaction, you know rate, if I'm moving my car, whatever the distance traveled, time taken, that is the speed, you know very well. Now same here in chemistry terms, with what speed reactants are getting converted into product, in what time reactants are converting into product, that is known as the rate. And rate of reaction is only dependent on one of the entity. You know that for a reaction to take place, 2 entities are required. What are those 2 entities? You know everyone that 2 entities are one is being reactant and another one is being reagent. It requires 2 to make a fight. It requires 2 to make a fight. So reactant is there, reagent is there, but rate is not dependent on reagent. It only depends on the reactant. That means for this reaction, rate of reaction is directly proportional to the concentration. This box, hey kids, box, this box is written, it means the concentration of reactant. That means to the concentration of reactant, power is 1. and the concentration of reagent power is 0. That means in the rate determining step, reagent is not involved. The power of reagent is being 0. That means how to think. Gayatri is there. Sir, I want you to complete. Okay, definitely. Sure. Kids, everyone hit the like buttons. Now see, kids. If I put in this plus the reactant is there. Let us suppose the reactant is Rx, alkyl halide. This reactant is over there in the flask. And the reagent is also there in the flask. Let us suppose the reagent is ROH or R-OH. Now, this reagent is also there. Both of them are there. But this reagent is not able to react. Or let me take the example of NCERT, the first example of NCERT. Let me take the first example which is given in NCERT. KOH, aqueous. Now see, if this reactant and this reagent and this water is there, how many types of entities are there? One is being reactant, one is being strong base, and another thing is being water. 3 type of entities are there, kids. Now let's see what type of reactant, what type of base, and what is the role of water in this reaction. So let me take the fresh page. Now, kids, one thing is very clear, that rate of reaction is equal to rate constant concentration of reactant power 1, where R is indicating rate of reaction. Let me write down these terms. They belongs to chemical kinetics. Then I will explain. This means rate of reaction. This stands for rate constant, also known as velocity constant, also known as specific reaction rate. Now, this is the concentration of reactant. Reactant can also be called as substrate. So this can also be given as R is equal to K to the concentration of substrate to the power 1, or nothing can be written over there. It can be like this, kids, right? Now let's see why the rate is dependent only on the concentration of reactant. Why not on the concentration of reagent? See, kids. The first example number 1, which is being given in your NCERT, I am just taking same example. Example number 1 of NCERT. Example from NCERT. That is being tertiary butyl bromide plus KOH aqueous, and the product formed is tertiary butyl alcohol, okay, plus KBr. Now see, kids, what do you think? If I'm going to write down the product, that doesn't mean anything. So just you think how the reaction is going to take place. Just try to see the structure of this tertiary butyl bromide. You will see the structure is like this: carbon, bromine, 1 CH3. It will take some time, but you will understand each and everything, kids. And we have to understand. Just think that not only completing the syllabus is required, you have to understand. This is tertiary butyl bromide, and this is being carbon delta positive, and this is bromine delta negative, and this bond is being polar bond. And we know very well that this is bonding molecular orbital, BMO, and just behind it there is ABMO, anti-bonding molecular orbital, which is being empty. This is being empty. This is being filled with electron. This ABMO is empty. Kids, are you able to understand? This ABMO is being empty without electron. Now, this is being a strong nucleophile. Why it is being a strong nucleophile? See, K positive, OH negative. One is being OH negative and this is being water. Kids, now the ball is in your court. Do let me know. This water is having just partial negative charge. And this oxygen is having, OH negative is having complete negative charge. Who is strong nucleophile? Kids, do let me know. This is being a strong nucleophile and this is being poor nucleophile. Now just try to understand who is supposed to attack on this reactant. Do let me know who is supposed to react on this reactant. Kids, if you are not able to understand, if you are not applying your brain, too much lag will be there in your life, not only in the syllabus. Nor I am talking only for NEET examination. The whole life will be lagging. Just always apply your brain. Do let me know fast. Kids, speedily try to give the answer. If you're not giving the answer, then you won't be able to understand. Kids, yes, this is being a strong nucleophile and this has to attack, but this is saying, oh, you are too much sterically hindered. That's why I can't attack because I have got habit of attacking in single step. This is saying I have got habit of attacking in single step. What this strong nucleophile saying? Strong nucleophile says I am having habit of attacking in single step. Attacking in single step. Kids, are you getting my point? Attacking in single step. But you are too much sterically hindered, so I'm unable to attack. Too much sterically hindered. You are too much sterically hindered, so I cannot attack in a single step. This tertiary butyl is too much sterically hindered. So in single step reaction can't take place. If it could have reacted in single step, then definitely it should be known as SN2 reaction, and that's why tertiary alkyl halides do not show SN2 reaction. This is the reason why tertiary alkyl halide do not show SN2 reaction. Now water will say, I'm poor. What I can do? So tertiary alkyl halide is singing a song. See what this tertiary alkyl halide is singing a song for this water. It is saying, hey water, this carbon is singing a song for water. Everyone, are you ready? Are you ready? This carbon is singing a song for water. Gradually, come into my life. Gradually, do sylvolysis. Gradually, steal my hearty halide. Gradually, make me carbocation. You know, if you dip kidney bean, you know, rajma in water, what is going to happen? You will say rajma will swell up. No, kids, rajma will just become wet. But if over the night, if you add this kidney bean inside the water, if you put this kidney bean inside the water, the rajma will swell up. So whatever the water is going to do, water will do slowly. And there is benefit also. See, if not slowly, we are just going to take a bath, water will come. We are going to take a shower, water will come and will swell up. No, it's not happens very soon, gradually. So if too much water, you must have seen dead bodies, they are inside the water and they get swell up, and then that's why they start floating like a ship. They start moving. So whatever the water is going to do, what is universal solvent, what water saying that whatever I'm going to do, I will do gradually, slowly, 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 slowly. So this carbon knows very well the water, and this carbon is singing a song for water. Gradually, gradually, slowly, slowly, come into my life. Slowly, slowly, attack on me, oh Pepsi water. Pepsi water means what? Why he's saying Pepsi? Pepsi is the cold drink. No, 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 no. It's not the Pepsi, is not the cold drink. It's Pepsi means polar protic solvent water. Water is an example of polar protic solvent, and whenever you are provided with polar protic solvent, they always do the solvolysis of cation as well as anion. Kids, first of all, do let me know in the chat section you are liking, you are able to understand, because we are not going to provide you bookish language. This is the topic which really requires strong understanding. So I'm here, I'm telling you, if you're liking it, do let me know. So this carbon is, once again I'm telling you what it's saying, slowly, slowly, gradually, gradually, come into my life. Slowly, slowly, steal my hearty halide. How much do you love me, oh Pepsi water? Do hydrolysis and make me carbocation. So it is going to make it carbocation, but this carbocation formation is a very, very slow step, and that is the slowest step. So I'm going to tell you the mechanism of this reaction. So see the mechanism. Everyone, let's see the mechanism. Whenever you are going to deal with SN1 reaction, the step number one is always slowest step, and that is rate determining step. Solvation. In case of water, we can also say solvation is hydration. And this step is slowest step and rate determining step. Always remember that this is being slowest step, and slowest step is rate determining step. Why it is being rate determining step? If you are in the class and everyone is noting down the lecture of teacher, then the one who is being slowest, hey Ramu, have you noted down? Everyone will say, yes sir. Ramu saying, sir, please wait for 2 minutes. I have not noted down. Then teacher has to wait. So the one who is slowest in the class is going to decide how fast the teacher is moving. Right now, you're not writing anything. You're not writing over here anything. Oh my God, Buddha Surya is writing energetic star. HSP sir is hero here. So our energy should be high. Yes. So if you're writing everything, the one who's saying, Ramu is saying, sir, please explain it once again. So I have to teach it once again. And then that Ramu is going to decide how fast I'm moving. But you're not writing anything. Now kids, slowest step is rate determining step. Now let's see why this is the slowest step and why this is going to be the rate determining step. I'm saying this is being tertiary butyl bromide. This is being tertiary butyl bromide. Now water will come. Water will come like this. This is having delta negative and this is having delta positive. So water will approach like this. HOH. Water H plus will come like this. HOH. And here the negative part of water will approach, and it will surround from all these sides, because water is being universal solvent. So it will do solvolysis slowly. Now why slowly? See, once this bromide is going, bromide is, always remember that. Your HSP Baba always used to say, and right now also saying, that atoms are like human beings and electron is like money. Electron is like money. Now see kids, this bromide is saying I am being more electronegative I am being more electronegative, so I will take away this electron, and carbon you will feel electron deficient. Carbon you will look like this. You will look like this. And now carbon you are just with only 6 electrons, only 6 electrons in the valence shell. In the valence shell. Now kids, do let me know which is being more stable. This carbon was having 8 electrons in the valence shell. 8 electrons in the valence shell. Now only 6 electrons. Which side it is being more stable? Gopika is there. Hello Gopika. Shiva Kumar. Hello. Now kids, this is octet is complete. Octet is complete. And there octet is incomplete. So this is being more stable. This is being more stable. More stable. And that is being less stable. Less stable, kids. It is being less stable. So the equilibrium will lie more in the backward direction and less in the forward direction, and that's why it is being slowest step, and slowest step is the rate determining step, RDS of the reaction. Kids, everyone is able to understand. And this side, the bromide is going away from the life of carbocation. This bromide is leaving. Hearty halide. Hearty halide is leaving, so this is leaving group. Lg is leaving group. Kids, whoa, Gopika, thank you. Everyone, do let me know that everyone is able to understand till now. Now this is about step number 1. Step number 1, this is a reversible step. Reversible step, and the equilibrium lies more in the backward direction. More in the backward direction, because this reactant is more stable and the carbocation is being less stable. Now see the second step. Get second step. In the second step, what is going to happen? Always remember that second step, attack of nucleophile. Attack of nucleophile. Now kids, nucleophile will attack from the front side or back side. Let's see. This is a very, very important point, and here the students are mainly getting confused. See, this is carbon, this is one valency, this is another one valency, and this is the third valency. You can see very clearly, or let me draw it like this. Always think like that. Whenever the carbocation is there, you have to think like this. And this is R1, or because R was CH3, so this is CH3, this is CH3, and this is also CH3, and this carbon is having positive charge, and it is having pure p orbital. Kids, it is having what? It is having pure p orbital like this. Now pure p orbital is a lengthy one. If I say these are the hybridized one, then they will look like this, because they are having S character. So some thicky sp2 hybridized. sp2 hybridized means one part of S and two parts of P. So they are being sp2 hybridized. It is sp2. The three are being sp2 hybridized. sp2. But this is being pure p orbital. Do remember, this is being pure p orbital, kids. Pure p orbital. How it will look like? Let me show you. Just give me a second. Pure p orbital is like this. See, this is trigonal planar. The sigma bonds are trigonal planar. Can you see? Sigma bonds are trigonal planar. It's like this. Y. See, it's Y. You can see clearly this is being Y. And the pure p orbital is like this, going above the plane, as well as below the plane. Or if I draw it like this, the one lobe is going towards the right hand side and another lobe is going towards the left hand side. Kids, are you able to understand? And this is being trigonal planar. Why I am telling you this thing in that much detail? Kids, once if you have studied SN2 reaction, we were always talking about steric hindrance, because in SN2 reaction, carbon was bonded with 4 valencies. But here, in carbocation, carbon is bonded only with 3 valencies. This is pure p orbital. And on this orbital, who is going to attack? The nucleophile is going to attack nucleophile. Now see, from the life of carbon, bromide was leaving. So from which side the nucleophile's probability is more to come? This nucleophile will attack more from the front side or more from the back side. Do let me know, kids. Which is front side, which is back side will depend on that. This is leaving group. The leaving group is going from this side, from whatever the side leaving group is going. From whatever the side leaving group is going, that will be known as front side. This is your front side. And the opposite of that, 180 degree of that will be known as back side. Now see, kids, from the life of carbon, this is leaving. It is having electrons. This is rich. And the new one is coming and X is going. This X is going and new is coming. Kids, this is being X. X means halide. X is leaving and new is approaching. From which side nucleophile will come more attack? Kids, thank you. Saturn rings. Thank you for your wishes. That's really fantastic. Thanks. Now kids, from front side, Priyanka is writing from front side. Everyone else, do let me know from which side they attack. See, from the life of carbon, this X is going and this is coming. Both are rich, both are having electrons. So here electronic repulsion will be maximum electronic repulsion. Maximum electronic repulsion. Kids, you must have seen one movie, Garam Masala movie. There was Akshay Kumar. From the life of Akshay Kumar, from the front gate, one of his girlfriend was going, and at the same time, air hostess, the another girlfriend, that was about to get the entry. Now do let me know whether that girlfriend has to come from the front side or back side just to avoid repulsion. Back side is more favorable, because I'm not talking about steric repulsion, steric hindrance. I'm talking about electronic repulsion is more. So this attack, front side attack is less. Front side attack will be less. And the back side attack generally in most of the cases, this attack is dominating attack, but attack will be from both the sides. Now kids, nucleophile is singing a song. Nucleophile is saying, I'm in love with the shape of you and thinking of attacking too. What the nucleophile is singing a song, kids, do let me know. This nucleophile is saying, I'm in love with the shape of you and thinking of attacking too. Now carbocation is saying, I'm being planar. With pure P per P or B. With pure P per P or B. What is this? With pure P per P or B. I'm being planar. With pure P per P or B means I'm being planar. I have pure P orbital and which is perpendicular to the plane of paper. If the plane is like this, the p orbital is moving like this. If plane is like this, p orbital is moving like this. Everyone is able to understand, kids? Do let me know. So this carbon is saying, how much do you love me, oh my nucleophile? Come and attack from the both sides, from the front side as well as from the back side. Now, this carbon is singing song for the nucleophile. Oh, my nucleophile, how much do you love me? Come and attack from the front side as well as from the back side. Now, the attack will always be from both the side, front side as well as back side. So, this is going to produce two types of products. See, kids, let me tell you, if the attack is from the front side, on this carbon, the attack is from front side, the product will be like this. CH3, 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 OH, and from the back side, attack, the product will be like this. Now, kids, just try to understand. This carbon is having only 6 electrons in the outermost shell. Only 6 electrons. Only 6 electrons. And this carbon is having 8 electrons. 8 electrons. What do you think? What do you think? Which is more stable? The product is being more stable. So this step is fast step. Fast step. Now you see, the nucleophile is involved in the fast step. Nucleophile was not having any role in the slowest step, but that was rate determining step. It is attacking in fast step. That's why it was not involved in the rate determining step. Now, kids, from this side, bromide has left from the same type, from the same side, OH is attacking. So this is known as front side attack. Front side attack. And this is known as back side attack, because this is attacking from the back. Back side attack. From east side, bromide has gone. So this is front side, from that west side, back side. Now, the front side attack is going to give you retention of configuration. Retention of configuration. And this is going to give you inversion of configuration. Inversion of configuration. And this backside attack is dominating, so inverted product is major. This is going to be major because backside attack is dominating, so this is going to be major. Now, kids, do let me know that this you are able to understand or not. Now, I'm going to draw the graph for this reaction as well as for SN2 reaction. Just try to understand graphical representation of both the reactions. First, let me draw the graph for the same reaction which I have explained right now. If I say on this line, if I say this is energy, this is being energy, and this is being progress of reaction. This is being progress of reaction. If I say this is being progress of reaction, and they are starting from here, this is being reactant, and this is the energy of reactant, and the reaction has gone like this. Now, by simply seeing the graph, this is your reactant, this is being your product. Could you please help me to let me know if examiner is asking this is SN1 or SN2? So you have to say this is the example of SN1 reaction. Why it is being SN1 reaction? This is intermediate. This is being intermediate, kids. Intermediate. Can you see? and these two are transition states. This is transition state number 1 and this is transition state number 2. Now from the graph it is very clear that this activation energy is high. You can see very clearly that this activation energy is high. Can you see? This activation energy is more than this activation energy. So which one is slowest step and which one is fast step? Can you see? This activation energy is high. This activation energy EA1 is more than EA2. So this is slowest step and this is fast step because this activation energy is high. High activation energy and that is low activation energy. Now you can see very clear number of transition states. From this graph we can draw one thing, number of transition states is equal to number of intermediate plus 1. You can see this is valley and these are two hills. Two hills are required to make one valley. Two hills are required to make one valley. So in the examination you can very clearly say this is SN1 reaction, and if they are going to ask whether this is exothermic or endothermic, so you can see this was the energy of reactant and this is the energy of product. Product is having less energy and reactant were having more energy. So if I want to say delta H, H final minus H initial or H product minus H reactant. So you can see very clearly this is less energetic, less energy. So the sum will come less minus more. This magnitude is more, negative. So this much is the difference, and this is an example of exothermic reaction. And exothermic reaction means they will liberate energy. So whenever you are doing any job, when you are running, extra energy means bad energy will get eliminated out with the form of sweat. You will feel relaxing. If you are doing exercise, some sweat will get released, some energy will get released. You will feel comfortable. That is being product is more stable than reactant. I will. Buddha Shurya, I will. So the product is being more stable. Kids, if it is clear, do let me know. In the chat section, do let me know that yes, this was more energetic, that is less energetic, and this is the difference. Now, if I compare this reaction with SN2, this was SN1. If I draw a graph for SN2 reaction, see what should be the graph? Once again, this is being energy. This is being progress of reaction. And the graph should be like this. This is being the energy of reactant and this is the energy of product. By simply seeing the graph, do let me know, kids, what you can see over here. This is being reactant and this is being product. There is no intermediate. This reaction is having just one transition state, simultaneous breaking and making of bond. This is involving simultaneous breaking of bond, BOB, and making of bond, MOB. What does it mean? Breaking of bond and making of bond. Kids, can you understand? No intermediate, because there is one transition state. Reaction is moving without any intermediate formation. So this is an example of SN2 reaction. SN2 reaction. SN2 moves without formation of any intermediate. I hope that this much is clear to all of you. Kids, do let me know. Show me the thumbs up if yes, everyone is able to understand. If you're not able to understand, thumbs down. But yes, quick I want to see the quick response kits, everyone. Now, I'm going to move towards second example. See, second example, very, very important. Second example. Everyone, see to it. Second example. Example number 2. If anyone is going to give you reactant like this, here is bromide, here is hydrogen, here is methyl, and here is being phenyl. Now you can see very clearly this carbon is being chiral carbon. Can you see? Chiral carbon. Now in front of this, there is KOH aqueous. KOH aqueous. Now the reaction is being carried out. You can see very clearly. People will start saying that there is steric hindrance. First there will be solvolysis, and once the solvolysis is going to take place, that is hydrolysis in case of water. So you can say solvolysis, and that is hydrolysis. Now once the hydrolysis is going to take place, it will form carbocation. The first step is being slowest step, and that is being rate determining step. So you will get carbocation, and carbocation will be like this. From the life of bromide has gone, this is being C6H5, this is being CH3, and this is being hydrogen, and this is the carbocation. What do you think? From which side the attack is going to take place? The front side or back side? Do let me know. So attack will take place from both the sides. From both the sides, the attack is going to take place from this side as well as from this side. The OH negative ion is going to attack. So you are going to get two type of product. That is in first step. First step, you are going to get two types of products. What are these two types of products? Though the name of products is, you can see very clearly, the two types of products are see everyone. Here the bromide has gone, so if I say retention of configuration, so OH over here, C6H5, CH3, and hydrogen, this is being chiral carbon, and this side, back side attack, OH is over here, this is being C6H5, this is being CH3, and this is being hydrogen. Both of them are having chiral carbon. Are they same compound or they are different? They are different because they are mirror images of each other. So I will say this is the product of dextro and levo, or we can say plus, minus, or we can say racemic mixture. So the examiner will ask whether the racemization will take place in this reaction or not. Backside attack is more, this is dominating, or we can say major product, and that is being your minor product. Kids, do let me know, in this reaction, racemization has taken place or not? Shiv Kumar, that's really fantastic. I'm liking that, kids, you are able to understand. So examiner will ask, in this reaction, question will be, this reaction will proceed with racemization? Yes. So racemization is taking place. Racemization is taking place. Now kids, how the questions can be framed on this SN1 reaction? Just try to understand. Question. I'm going to give you question number 1. Everyone see to it. Question number 1. Question number 1 is, arrange the following. Arrange the following in decreasing order of SN1 reaction rate. With reaction is taking place with KOH aqueous, KH aqueous. Now see everyone, the first reactant is being A1 is Br CH3 hydrogen. B is Br C6H5, and this cyclopropyl, it do dancing resonance hydrogen. C1 is hydrogen bromide, and D is bromide CH3. So could you please help me to understand which will have maximum rate, what should be the order for the decreasing order for rate of reaction? Everyone do let me know. I'm waiting for your answer. Yes, kids. CABD. Get C. Whose carbocation will form most easily? Do let me know whose carbocation will form most easily. Which carbocation will be most stable? If this bromide is going to leave, this carbocation will be resonance stabilized as well as will do dancing resonance. The cyclopropyl is responsible for dancing resonance. If you don't know the stability of carbocation, you won't be able to give the answer. So this carbocation is going to be most stable. So B. After B, this is stabilized by hyperconjugation, 9 alpha hydrogen. So this carbocation will have 9 alpha hydrogen atoms, and that was having dancing resonance. It's dancing resonance stabilization, and this D, C, B, D, and after this is simply methyl. This is 1 degree, and this is being 2 degree carbocation, 2 degree carbocation, 1 degree carbocation, 3 degree carbocation, and this is dancing resonance. So after that, AC, BD, AC. How many of you got the correct answer? Do let me know, kids. How many of you got the correct answer? This is the rate of BDAC. Wow, Priyanka, that's really fantastic. This is the rate of SN1 reaction. I'm going to tell you how to find out the rate of reaction. See, kids, always do remember that rate of SN1 reaction, is directly proportional to stability of carbocation. Stability of carbocation. Now you will say, sir, please explain. We have studied this thing everywhere, but we are not able to understand how and why. Just try to understand. Let me take 2 examples. Just see 2 examples I am going to take. One example like this. This is the first example. This is the second example. In the first example, let us suppose here we have got bromide, here we got hydrogen, here we got methyl, and here we got ethyl. And in second example, here we got C6H5, here we got the cyclopropyl, here we got methyl. Now, which carbocation will form easily? Do let me know. Both the carbocations are intermediate, highly unstable, but although both the carbocations are highly unstable, but then also which carbocation will form more easily? So the answer lies, this bromide will go taking electron. Who is going to take electron? Water. The solvolysis will take place, and this carbocation will be like this: C positive, CH3, and ethyl and hydrogen. This carbocation is not having any resonance, so this is without resonance, no resonance. It is having definitely what? hyperconjugation. How many? 3 and 2. So stabilized by hyperconjugation, 5 alpha hydrogen atoms, and stabilized by inductive effect, that is being 2-degree carbocation. I hope that you are able to understand. Now this carbocation, it is like this. C, and adjacent to it there is being phenyl, kids. Phenyl is like mother. Parents, P for parents, P for phenyl. Whenever the carbon positive is adjacent to phenyl, it will do resonance, and it is doing dancing resonance. So this carbocation is highly stable because of resonance as well as dancing resonance. Two types of resonance are there. So this carbocation is more stable, and that is less stable carbocation. I hope that everyone is able to understand till now. Less stable carbocation, this is being more stable carbocation. So what do you think, which carbocation will form easily? And this is being slowest step. Both are being RDS. Slowest step is being rate determining step. So both of them are slowest. This is also slowest, that is also slowest. Both of them are slowest, but this is unstable. Let us suppose it took 5 hours to form and it took just 3 hours to form, because this is being more stable. Now see, the second step is fast step. The OH negative will attack. OH negative will attack. Now you can see very clearly that on which carbocation OH is going to attack more easily. This is being less stable, more reactive. So OH negative will attack, let us suppose here, in 5 seconds. 5 seconds. And here the OH negative is taking, let us suppose, 30 seconds more time, because this is being more stable. So this is the main question. Maximum time kids are thinking that this is being more reactive, then why not this is going to be the more rate. Now see kids, if I say this product is formed, COH, CH3, C2H5 and H, both dextrolivo. This product is also formed C6H5, CH3, both dextro and levo. Now its total time which has been taken for this reaction is 5 hours plus 5 seconds. Can you see? 5 hours and 5 seconds. This reaction took place in total time of 5 hours plus 5 seconds. And this reaction took place 3 hours plus 30 seconds. Now 30 seconds and 5 seconds, they are negligible, and that's why slowest step is always the rate determining steps. Kids, are you able to understand why the slowest step? Akanksha Singh, good morning. Why the slowest step is rate determining steps? Kids, do let me know in the chat section that everyone is able to understand why the slowest step is rate determining step, and that's why rate of reaction is directly proportional to the stability of carbocation. That's the reason why rate of reaction is directly proportional to the stability of carbocation. Kids, do let me know that everyone is able to understand or not in the chat section. Do let me know that you got it or not, you are able to understand or not. This point, everything is clear. Oh great, let me have a sip of water. Just everyone, wow, yes sir. Arthi, Leo, Messi, Akanksha, kids, show me thumbs up. Yes, oh yes. Now before I move towards the third example, let me tell you the rank deciding concept. That concept is important for top 50 rank. Now I am going to deal with top 50 rank concept. Kids, what I am going to tell you, top 50 rank concept. What do you think? If attack is taking place from both the side, is it possible that attack could be 50-50, or always the backside attack is dominating? Kids, do let me know. Is always the backside attack is dominating, or it could be possible that in some example 50-50 attack can be possible? Do let me know. I'm asking to you, kids. Attack of nucleophile is from both the sides. Now, if the attack is from both the side, what do you think? The attack is from both the sides. What do you think? First question, that in SN1 reaction, racemization always takes place. In some example, it could be 50-50. Wow, Akanksha, how do you know? It depends on the carbocation stability. Future education, it depends on the carbocation stability. That already I have told you in GOC part 1, the stability of carbocation. Now see, attack of nucleophile is from both the sides. Now here two cases arises, kids. Two cases. Case number 1 and case number 2. Case number 1 and case number 2. The case number 1 is most general case. This case number 1 is most general case. What is that? In 99% reactions, backside attack is dominating. Backside attack is dominating. Because nowadays assertion and reasoning is coming. But in very rare cases, but in case number 2, and it is being experimentally determined. Experimentally determined, kids. Experimentally determined. I can't say that just seeing the reaction we can find out. Experimentally determined. Very, very rare case. Very, very rare case. Very, very rare case. What is this case? This case is indicating if the carbocation is highly stable. In case if carbocation is highly stable, then attack can be 50-50. Then attack can be 50-50. Now, what is the meaning of carbocation is highly stable, then the attack can be 50-50? What is the meaning of this thing? Now, see, kids. Future education is asking, sir, in case of SN1 reaction, what is the difference between stability? I will let you know. Now, see, kids. Let me take two carbocations and try to understand the concept. This concept is really very, very important. Otherwise, you won't be able to understand. These are two examples. Just see to it. Let me take first example and let me write down. This is being carbon. This is being bromide. This is being methyl. This is being hydrogen. And this is being ethyl. And in this case, let me say this is being C6H5. And this is being C6H5OCH3, and this is being this cyclopropyl and bromide. You can see very clearly this carbocation is less stable, and the below carbon is carbocation is going to be more stable. Now see, try to understand. Just see to it. Its carbocation will be like this: CH3, hydrogen, and C2H5. And its carbocation will be like this: C6H5, this OCH3 methoxy group, and this cyclopropyl. This is highly stable. Now from the life of this carbon, the leaving group, this carbon will say, hey leaving group, please don't go. I'm feeling highly unstable. So bromide will be somewhere here. But this carbocation is highly stable. So this carbon will say, hey leaving group, just go away. Go away from my life. I don't want to see you. So its bromide has gone away from the life because this carbocation is highly stable. Highly stable carbocation, kids, highly stable carbocation. Now, what do you think? The incoming group that is being attacking agent, in which case the attacking agent has got equal opportunity to attack from front side as well as from back side. Do let me know that in which case, out of these two cases, in which case the nucleophile, the incoming nucleophile, and this is the leaving halide, the incoming nucleophile is getting halide, its halide is gone. This is being nucleophile, this is being nucleophile. The nucleophile has got equal opportunity to come from both sides, front side as well as back side. You see in this case there is repulsion. Which repulsion? Electronic repulsion. Electronic repulsion. So which attack is going to be dominating over here? This is dominating attack. Backside is dominating. Now backside is dominating. So this will be responsible for major product. That will be responsible for minor product. But in this case, the attack can be from both the sides. Equal amount. This is 50% and that is 50%. So in this case, you will get complete racemization. Here, this is the case with complete racemization. Kids, are you able to understand? This is the case of complete racemization, and that is the case of partial racemization. I hope that everyone is able to understand. So more is the stability of carbocation, more will be the amount of racemization. So I can say the extent of racemization is directly proportional to the stability of carbocation, kids. Am I right or not? See, kids. So better to say the extent of racemization or the amount of racemization, the extent, or that is amount of racemization is directly proportional to the stability of carbocation. Now kids, that's why I have told you when I was teaching you GOC, at that time I have told you that stability of carbocation is really very, very important. If you don't know the stability of carbocation, you won't be able to do anything. You won't be able to understand anything. Now see kids, not only this much is required. What I am going to tell you, the extent of racemization is directly proportional to stability of carbocation, and simultaneously I am saying that rate of SN1 reaction is also directly proportional to stability of carbocation. So ultimately stability of carbocation order is very, very important, very, very important. And one more thing, it is the intrinsic thing of reactant. Who is going to form carbocation? That is Pepsi. If water is not given in all the cases, in one case alcohol is given, in one case water is given, so the rate of SN1 reaction is directly proportional to stability of carbocation as well as at the same time polarity of solvent. So these things we should have to have in our brain, otherwise we won't be able to do anything. We won't be able to give answer of their questions. So these things we should have in our brain. Now kids, do let me know that everyone is able to understand. Now, so if the rank deciding question is asked like this, arrange the following. Question is like this. See kids, question is like this. Arrange the following in decreasing order of extent of resmization. This is rank deciding question, kids. This is rank deciding question. Now see kids, the options are given like this. A is I C6H5 CH3 and C2H5. B is like this. I CH3 hydrogen CH3. Only two are given, only two. Just try to give the answer of these two, which will have more extent of resmization. Let me see kids, what's your answer? I'm waiting for your answer. Everyone do let me know. A, very good, Leo Messi. A and then B. That's really fantastic. That's really fantastic. So the answer is first A and then B. Fantastic. A, then B. Because its carbocation is being more stable. Now see kids, one very laddu question, easy kill question. See to it. Question is, in which reaction there will be resmization? There will be resmization. Really, this is going to be easy kill question, kids. And try to give me the correct answer. I will wait for your answer, kids. 1, 2, 3, 4. What they are saying, in which reaction there will be resmization with KOH aqueous. Now, A1 is, this is chloride, this is methyl, this is methyl, this is being methyl. B is like this. This is hydrogen, this is hydrogen, this is chloride, this is hydrogen. C is like this. This is C6H5. This is hydrogen, this is methyl, and this is Cl. D is like this. This is ethyl, this is hydrogen, and this is Cl. Kids, what's your answer? I'm waiting for your answer, kids. Do let me know what's your answer. Wow, Leo Messi, Akanksha Singh, you are really rocking that this is your answer very fast, because this carbon is chiral and its product will be chiral. This is not chiral, 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 not chiral. Now, one question. See, true or false? This question is based on true and false. You have to find out the answer, true or false. True, false. SN1 reaction always proceeds with resmization. With Racemization. Is this statement true or false? SN1 reaction always proceeds with racemization. Is this true or false? Kids, do let me know. False. Fantastic. Who has given the answer? Priyanka. Wow. Priyanka, great. I've become fan of you. Leo Messi, Akanksha, Priyanka, Bratan. Kids, really awesome. Really awesome. You are rocking. Rocking, kids. Rocking. Now see, another statement if I write that statement number 2. See, this I haven't taught you, but let me check it out. Second, that SN1 reaction always proceeds with rearrangement. This till now I haven't taught you, but I'm going to teach right now. Right now I'm going to teach you, but first of all, do let me know what's your answer. SN1 reaction always proceed with rearrangement. True. Shiv Kumar is writing true. Akanksha is writing true. Priyanka, Buddha, Shurya, everyone is writing true. The answer is gets false. So see kids, in this case, your answer is wrong. You have been proved to be wrong, kids. Now, let me tell you. You must have seen that during winters, if you're wearing out your sweater or jacket, and suppose in the morning temperature has gone down, then what do? Your jacket's hoodie comes up, yeah, ooh, and your sleeves comes down, ooh, you feel like this. And if during the lunchtime temperature has been increased, then your sleeves goes up. Your sweater must come over here or over here. Somebody must have seen that moving with his sweater like this. This is the rearrangement. By chance, if in your home there is some puja type, Aarti puja, puja means God puja. So when you are allowed to sit with folded legs and after some time you feel uneasy, steric repulsion is there, strain is there, then you try to uplift your legs or you want to try to sit on the chair. That is rearrangement. If by doing rearrangement, yeah, you will learn it. Just do let me know. Let us suppose if you have gone to Shimla in one party and you have then received from a call from your institute that you have been selected in your NEET examination and we are throwing a party, just come fast. Do let me know. When you are going from your party, the original party, the relatives party to the institute party, will you change your uniform, whatever the dress you were wearing, you are going to change it or you will come in the same uniform? Do let me know. To the college party, institute party, you will come in the same dress you are wearing out or you will change it? Do let me know. You are going to change your dress or you will come in the same dress? Everyone, do let me know, kids. Buddha Surya is saying change. Others, Akanksha is saying change. Everyone is saying change. Kids, by chance, if you are having the best dress which you are wearing in that party, birthday party, or it can be any type of party, and at home you are not having better than that, or at home you are having the same type of dress, then what you are going to do? You are going to change it. Those who are having, they will change it. Those who are not having, what they will do? They will come straight forward or they are going to change it. Kids, do let me know. So, two possibilities are there. If you are having better dress, better clothes at your home, you are going to change it. If you are having not better than those or the same type, you are not going to change it. So do remember, rearrangement may take place. It's not always it is going to take place. Do remember what I am telling you. In SN1 reaction, and this is the mistake done by maximum student, that they always say that rearrangement will always take place. No, in SN1 reaction, rearrangement may take place. May, you know, the English word may, kids, this is very confusing word. May I come in, sir? In the class we were using without knowing the meaning. May means can take place or cannot take place. It's not necessary that in SN1 reaction rearrangement may take place. May take place. May take place. Remember, it's not April, May, June, July. May take place. So, if by doing the rearrangement, stability is coming. What I'm saying? If through rearrangement, stability is coming. If carbocation is getting stabilized. If carbocation is getting stability, through rearrangement, then only rearrangement will take place. Then only it will take place. Otherwise not. Otherwise not. Kids, are you able to get it? And what are the types of rearrangement? I am going to explain all type of rearrangement. There are 3 types. What are the 3 types of rearrangement, kids? These 3 type of rearrangements are hydride shift, 1, 2, hydride shift, 1, 2, methyl shift, ring expansion, and we have to understand these type of rearrangement if we want to understand the organic chemistry. Is everyone ready, kids, to understand it? Do let me know that if you're ready. Everyone, do let me know that yes, you are ready. So is everyone ready, kids? Do let me know the type of rearrangement. And this thing must be clear. May take place, may be or may not be. May means maybe or may not be. That's, it's not compulsory that it's going to. See, 1, 2 hydride shift. 1, 2 hydride shift. What's that? Try to understand, everyone. 1, 2 hydride shift. What is the meaning of 1, 2 hydride shift? That also I am going to tell you. 1, 2 hydride shift. Just focus on this carbocation. This is your carbocation. CH3, CH, CH3, CH positive, CH2, H. Let me change the color. This is green color hydrogen and this is yellow color hydrogen. In the examination, you will get same type of color. In the examination, color will not get changed. Now, first of all, try to understand this carbocation. Is there any resonance in this carbocation? Is there any resonance in this carbocation? Do let me know. No resonance. Sir, when you know very well that there is no resonance, then why you're talking about resonance? Why you're giving that much importance to the resonance? It's to ignore resonance is impossible. Resonance is like God. Whenever any function is going to happen in your home, the first bite to whom you are going to serve, the first bite is always given to God. We know that God is not going to eat it, but just thinking in our brain that by chance, if God is feeling hungry, if God is starving, then God should be get the first priority to have that food. So always think about resonance. Although we know that may be possible, may not be possible, here resonance is not possible. So here is hyperconjugation. So this compound is stabilized by hyperconjugation. How many alpha hydrogens? 2, 1, 3 and 1, 4. 4 alpha hydrogen atoms stabilized by inductive effect. It's SBI, not State Bank of India. State Bank of India, no. Stabilized by inductive effect. This carbon is attached with one carbon, 2-degree carbocation. Is it clear? So this is the data for this one. Now there are two possibilities. Either this hydride can shift or this hydride can shift. What do you think? This hydride, if this hydride is going to shift, what you are going to get? See, by chance, if anyone is going to shift this hydride, then what is going to happen along with electron? If this hydride is going to shift over here 1 to 2 position, then this carbocation will look like this: CH3, CH, CH3, CH, H and CH2 plus. What do you think? Is this carbocation is more stable than earlier or less stable? This carbocation is more stable than earlier or less stable? Definitely no resonance. Stabilized by hyperconjugation, but how many alpha hydrogens? Only 2 alpha hydrogen atoms. And stabilized by inductive effect, what is the degree? 1 degree. So this is not possible because it is less stable than earlier. So this way is wrong. Less stable, so not possible. Now if I do the shifting of this hydride, 1, 2 hydride, this hydride is going to shift over here. Get see what type of carbocation we are going to get. We will get definitely this type of carbocation. See to it, everyone. What type of carbocation we are going to get? We will get CH3, C positive, CH3, CH2, CH3. Now this is also not having a resonance, no resonance, but you can see stabilized by hyperconjugation. How many alpha hydrogen? 3, 3, 6 and 2, 8 alpha hydrogen atoms, and stabilized by inductive effect. Degree is 3 degree. What do you think? This carbocation is more stable than the earlier one or less stable? Definitely this carbocation is more stable. But remember that not only this carbocation is going to form. What I am telling you, the more stable carbocation is going to form more. The less stable carbocation will be formed less. There are n number of molecules. Suppose 1 mole, then 6.023 into 10 raised to power 23 molecules are there. So always remember that the more stable carbocation is going to form more. Now you will say, sir, this is least stable, then in that case this is also going to form. No, we have started from this reactant. This is a starting material. From this there are two ways. Either this can happen or that can happen. That can never happen because that is less stable than this. Only this process can happen. So two types of intermediates you will get over here, X as well as Y. Y is being more stable, so more formed, more stable, so more formed, more responsible for product, more product formation. Gets till now, is it clear to all of you? Hydride shift, from which side hydride is going to show the shifting and why the shifting is taking place. Kids, everyone, do let me know that everyone, is it clear to all of you or not? I'm waiting for your answer, kids. Do let me know. Yes. Till now, is it clear to all of you or not? Show me the thumbs up if you are able to understand till now, because next is I'm going to tell you methyl shift, and then I will let you know ring expansion, and then we'll do some questions based on it. Vedha Janani, very good morning, very good morning. Now see kids, 1,2 methyl shift. This one to you can understand by yourself. See, it's really very awesome. 1,2 methyl shift. Why it is known as 1,2? Are you able to understand 1,2 methyl shift? Suppose if the carbocation is like this, CH3, C positive, CH3, CH3, CH positive, CH3. Now kids, you can see this carbon, the adjacent carbon is not having hydrogen. Whenever there was hydrogen, hydride shift took place, but there is no hydrogen, so definitely this methyl along with electron, that's why it is known as methyl CH3 negative methyl shift. So 1,2 methyl shift will take place. Why it is 1,2? From one carbon it is going to second carbon, there it's formation of ring, three-membered ring, that's why it is known as 1,2. Now see, this carbocation is going to provide more stability or less stability. See, just try to understand. CH3, C positive, CH3, CH, CH3 already it was there, and this one CH3 after shifting. So two types of carbocations we are having. Which carbocation do you think is more stable? First one or second one? Just compare. This carbocation is having resonance? No, sir. No resonance. Is this carbocation is having resonance? No, sir. No resonance. Both of them, they are not having any resonance. This carbocation is having how many alpha hydrogen? 3. This side, no. So stabilized by hyperconjugation, that is being 3 alpha hydrogen atoms, and is stabilized by inductive fact, that attached with 2 carbons, so 2 degree. Now let's see this carbocation. This carbocation is stabilized by hyperconjugation. How many alpha hydrogen? 3, 3, 6 and 1. 7 alpha hydrogen, right? Now stabilized by inductive fact. What is the degree? This carbon is attached further with 3 carbons, so 3 degree. This is the data of both the carbocations. Do you let me just do let me know kids, which data is looking more handsome, which carbocation is more stable? So definitely the right hand side carbocation is more stable, and more stable, more formed. More stable, definitely more formed, more formed, more responsible for product formation, more responsible for product formation. Is that clear to all of you? Both the carbocations will get formed, but the more stable carbocation will be more formed. Now, the very, very important one, ring expansion. This is going to be the killer one, kids. Don't miss this ring expansion. Nowhere you are going to understand ring expansion like this. Which ring is going to expand, which ring is not going to expand. First, let me tell you which ring will never show ring expansion. Ring expansion. This is really the killer topic, kids. Ring expansion. Always remember that whenever the ring is given like this, what's special in this ring? This ring is stabilized by dancing resonance. This ring is stabilized by what, kids? This ring is stabilized by dancing resonance. So this ring will not show ring expansion, no ring expansion, no ring expansion, no ring expansion. No ring expansion. Now kids, should I tell you one thing? This is the normal study that there is no ring expansion. But if you want to see in more detail, if you want to go in the depth of this, then let me tell you. Whenever you are provided with this ring, kids, whenever you are provided with this ring, just try to understand this ring. Right now I said there will be no ring expansion, but if you want to go into the depth of it, then ring expansion takes place. But how much? See, how much? That side less and this side more. The equilibrium lies more towards this direction, and with the ring expansion, what is it is going to form? It will form a product like this. The forward side, I will say, this is ring expansion. It is given in J.D. Lee, Stuart Warren, Claydon. And this side, from that side to this side, it is known as ring contraction. And there is one reaction given known as Stiffno-Diemza reaction. No need for your syllabus. That reaction says that this amount is 51% in the solution, and this amount is 47. Now kids, you must be thinking, sir, 51 plus 47 is how much? Sir, only it is how much? 2% is still left. Where has the 2% gone? It's 2% is elimination reaction. 2% is alkene. So what do you think? The equilibrium is lying more toward this side, and that side equilibrium lies more toward this side. This is more stable, and that's why we used to say that ring contraction takes place, ring expansion does not take place. Kids, this is the true thing about this. People used to say that no ring expansion. People used to say ring contraction. Both will take place. Why both are taking place? Let me tell you. This carbon, according to science, is supposed to be sp3 hybridized, but this angle is 60 degree only, and this is also supposed to be sp3 hybridized, but the angle is 90 degrees. So what do you think if I compare from the sp3 hybridization says the bond angle must be 109 degree. So 109 degree minus 60, how much is the strain? 49 degree strain is there. 109 degree minus 90 degree, how much is the strain? 19 degree strain is there. So here the angle strain is less, here the angle strain is more. So in this less angle strain, here more angle strain. Now kids, you might be thinking, sir, what are you doing? What are you saying? If there is more angle strain, then why it is more dominating, more stable? Kids, it has got the stability due to dancing resonance. It is having dancing resonance stabilization. That's why it is more. So this reaction, both are in handsome amount, but that is a little bit more because of dancing resonance. Kids, if you are able to understand, do let me know in the chat section. Yes, sir, we got it. We are able to understand. Each and everything is coming to our brain. Kids, everyone, do let me know in the chat section that really it's awesome. Till now, I haven't taught in the old fashioned way that everyone is going to teach you that this is the ring and this will do the ring expansion. Not, I have not done like that. Now see kids, to happen the ring expansion, what is required? For the ring expansion, the charge should not be present. Charge should not be present directly on the ring. If the charge is present on the ring like this, charge is present on the ring like this, no ring expansion. Ring expansion will never take place. No ring expansion. Sir, what is ring expansion? Please tell us that. No ring expansion. For ring expansion to take place, what is required? What is required? See, the ring should be like this. Here plus charge, at which place? The plus charge should be over here. Then the ring expansion will take place. Now see how the ring expansion is going to take place. Suppose if I am being the carpenter, then what I would have done, I must have cut with the help of hammer. I must have hammered with the nail. If I am being the carpenter, what I would have done, I must have done the cutting from here and I must have done the stitching over there. But I am a poor chemistry teacher. Okay, I'm just a teacher. Why poor? I have to gain more knowledge. I have to gain more stability. So everyone is poor, everyone is rich. It's just the way of thinking. Now see kids, let's what they are talking. In my sense, I know how the chemicals they are going to talk. Just see how the talk of chemical is going to take place. Let us suppose this is X carbon, this is Y carbon, this is Z carbon. Z carbon is saying, hey Y carbon, please lend me your electron. Y is saying, oh, what are you saying? If you are giving my electron, I will feel positive charge and there will be more repulsion and you will get negative charge. Z is saying, oh please, oh my dear, just try to give me your electron. I will let you know what I am going to do. Okay, so have it. So see kids, this Z carbon has taken electron of the Y carbon. So it will look like this. See to it. It will look like this, CH2 partial negative, and it is going to lose. So delta positive, and it is already having positive charge, full positive charge. So this carbon is breaking the bond from here. It is breaking bond from here. This is breaking of bond. And it is going to make bond over here. This is making of bond. See, electron triangle. You must have seen in movie love triangle. You have heard about love triangle. But here is electron triangle, three-membered ring, highly unstable. So this bond is breaking from here. Breaking of bond. And here the making of bond is taking place. Making of bond. So you can see very soon what is going to happen and how the ring expansion is going to take place. See kids, try to understand. It's like this, it's like this, it's like this, it's like this, and this new bond has been formed right now. This new bond has been formed right now. You can see clearly this new bond has been formed right now, and this is having positive charge. So this is 5-membered ring. You can write it like this, or you can draw it like this. Both means same. So both the two rings are same. This is 4-membered ring has expanded to 5-membered ring. 4-membered to 5-membered. And this is a great relief. 5-membered ring is more stable than 4-membered ring is being less stable. Now see kids, what is the stability of ring? Always remember that without any functional group, 6-membered ring is more stable than 5-membered ring, than 7-membered ring. These are the stability of the rings. You have to keep this thing when you are solving any question. You should have to, oh, 5 and this is being 7, 7-membered ring. You should have to have in your brain to solve any question the ring stability order. Ring stability order. Now see kids, how the 5-membered ring is going to convert into 6-membered. Everyone see to it. This is your 5-membered ring. And if you're not able to understand in one go, just you can ask, don't feel any hesitation. The same thing, this is 5-membered ring and the same talk in between these two carbons. Hey carbon, please give me your electron. Then this is going to get delta negative charge and this is going to get delta positive charge. And now it will start forming a bond over there. With which carbon? It will start forming bond with this carbon. So electron triangle. So what is it going to do? See, the bond is going to break from here. The bond has been broken out and it will look like this. Just see everyone. The bond is breaking from here. Breaking from where? The bond is breaking from here. This is breaking of bond and that is going to be making a bond. Can you see kids? Everyone just try to understand. Is it clear to all of you? From one place this is breaking a bond and another place that is making a bond. Now you will see very soon what is going to happen. It will be like this and this bond has been formed and here is positive charge. Either you can draw it like this or you can see 6-membered ring and we can see 6-membered ring like this. Both mean same, either this or this. It's not only that ring will get formed, this ring will also form the product. This is less stable, so less formed. That is more stable, so more formed. Now I'm going to give you the best version of this the examiner can ask. Now see how another type of 5-membered ring to 6-membered ring. Just see to it. If the ring is given like this, see kids, it's really awesome example. If the ring is given like this is your 5-membered ring and what can happen, see kids, if this is the plus charge and here is CH3. Along with ring expansion, one more thing is supposed to happen over here. See what's that? In one molecule, the ring expansion has took place like this. This carbon has withdrawn electron. This has developed partial negative charge. That is going to develop partial positive charge and this will form a bond over here. Now, the bond has been formed and you can see this is the new bond. And there was CH3, CH3. Now just try to understand. This bond has been formed over here and this was attached with CH3. You can write it like this or you can write it like this also. Now, number of times after having your lunch or dinner, what do you want? Do let me know in the chat section. After having lunch or dinner, what do you want? Some sweet, some dessert, ice cream, chocolate, laddu, gulab jamun, whatever the type of things you want to have that. Now see, this is saying that I was 5-membered ring. I'm happy that I got converted to 6-membered ring. So I'm very happy. But you see, how many hydrogens, alpha hydrogens I'm having? 3 alpha hydrogens. I'm not having any resonance, no resonance. Stabilized by hyperconjugation, but only 3 alpha hydrogen atoms. Stabilized by inductive effect, but only 2 degree. If what would happen, then I would feel very happy. If what would happen, so that I can feel very happy if this hydrogen shifts. Hey dear hydrogen, please do let me know, will you shift? Will you change your position? Will you come here along with the electron? Dig, 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 dig. Gradually come into my life. Hey hydrogen, give me, provide some stability. How much do you love me? Show me your love. To the 1,2 hydride shifting. Along with ring expansion, I would like to have the hydride shift also. So along with ring expansion, there will be hydride shift also, and you will get this carbocation. So how many carbocations till now you got? If I say this is your X carbocation, this is your Y carbocation, and this is your Z carbocation. So out of these 3 carbocations, you can see very clearly this carbocation, this plus charge is over here. This plus charge is at this position. Now, no resonance, stabilized by hyperconjugation. How many alpha hydrogens you can see? 1, 2, 3, 2, 5, and 2, 7 alpha hydrogen atoms. Got stability and stabilized by inductive effect, that is 3 degree. So which carbocation is being most stable? Z is being most stable. So maximum form, then Y, and then X. They all will be responsible for product formation. Kids, everyone got it? Now, not only these 3 carbocations are going to form, one more additional carbocation will form. That's why it is very, very important. See kids, along with those 3 carbocations, one more carbocation will get formed. See why and how. You know that if there is 1 mole of anything, that means 6.023 into 10 to the power 23 of those molecules. So 1 molecule must be doing this, 1 molecule must be doing that. So different type of molecules must be doing different type of things. Just like in marriage gathering, somebody is having in the plate salad, chutney, pickles, then paneer, chapati, like that. Some other people, what they are doing, they are having fruit chaat, idli dosa. So what third type of people are going to do? They will start from the ice cream only. They are saying, oh, always I am having chapati in my home. Always I am having dosa in my home. If they are South Indian, dosa. If they are North Indian, maximum they are having chapati. They will say, oh, I never get ice cream. Father always scold me to have ice cream, that you will feel cold and like that. Let's have ice cream, ice cream, ice cream. Some others must be fond of sweets. Oh my God, this is cake, this is that, this is that. They can. So different type of people have got different choices. It depends what type of people are there. That depends on their further type of choices. So here also, when we talk about compounds, number of compounds are there and number of types of choices are there. One is doing that, this is doing that. This is saying, oh, let them do ring expansion. Hey hydrogen, do one thing. Come here along with your electron. Come here along with your electron. We will do this. What is this? See kids, what is the stability gained by this, by doing this? Now see, it is having positive charge, and this hydride along with electron is going to shift over here. Now, is it going to get any benefit? CH2, CH3. Now see to it. Right now, the ring is 5-membered. This is 5-membered ring. That is also 5-membered ring. Not too much stability they have gained. 5-membered is remaining 5-membered only. But this is having how many alpha hydrogens? No resonance. no resonance. So is there hyperconjugation? Yes. Stabilized by hyperconjugation. How many alpha hydrogen? 3 and 1, 4. 4 alpha hydrogen atoms. Stabilized by inductive effect. What is the degree? This carbon is attached with 2 carbons, 1 carbon, this carbon, 1 carbon, this, 2 degree. Well, let's see. Any resonance? No resonance, boss. No resonance. Now, stabilized by hyperconjugation? Yes, sir. Of course, why not? How many alpha hydrogen? 2 over here, 2 at this place, and 2 at this place. 2, 1 ja 2, 2, 2 ja 4, 2, 3 ja 6. Oh my god. 6 alpha hydrogen. Stabilized by inductive effect? Yes, sir. It is attached with 3 carbons, 3 degree. So this carbocation is being more stable. This carbocation is being less stable. So it should be like this. So this is another carbocation. Let me tell you, if this is carbocation number, if I say XYZ, and this is M. So definitely these two are 5-membered only. 6-membered is going to be more stable. So the stability order will be, first of all, Z, then Y, ZY, Z, then Y, then M, then X. This should be the stability order. All they will form product, but major product will be formed by this stability of carbocation. Kids, I hope that everyone is able to understand. Now I'm going to give you a question. Definitely you can do that. Oh my god, Priyanka has given, Akanksha Singh has given the answer. Now see, kids, I'm going to give you the question of aims that might be coming to NEET, and they can definitely ask. Try to answer it. Simple question. The first question is simple one. Find out the major product. The question is find out the major product. The reaction is given like this. This is being C6H5, CH, CH3, CH2, or CH, Cl, CH3, and this has been treated with. Just think like that you are giving the original exam. You have to answer it. Don't take it lightly, anyone. No one is supposed to take it lightly. KOH, aqueous. So this is the reaction. You just try to find out the answer. I'm giving you total 1 minute. Kids, everyone do let me know what answer you are going to get. Everyone do let me know what answer you're going to get, kids. I'm waiting for your answer. So, sir, how to write? Sir, I've got the answer, sir. How to write? You're too far. Oh, no, I'm here only. I'm going to write the answer. For the options I'm going to give you, you have to let me know which is major product, kids. So, just to let me know, what do you think? Is this your major product? Is this your answer? Is the option A is your answer for major product? Is this, they have asked about the major product, major product. Is this the answer? Hey, is this the answer? Do let me know, everyone. Is this the answer? A option. So, no, sir, this is not my answer. Okay, then do let me know. Is this your answer? Is this your answer? Kids, too, let me know. Is this your answer? The B1 is your answer. Yay! Hippe pure, you got it. You are rocking. You are star of this day. Kids, rocking. Yes, I feel. Now, in this question, you are winner. This reaction, if examiner is asking in this reaction, what has happened? What has taken place? Ring expansion, hydride shift, or methyl shift? Ring expansion, hydride shift, or methyl shift? What has happened? So definitely answer is this reaction has proceeded with hydride shift. Am I right? This reaction with hydride shift, it has taken place with hydride shift. Am I right or wrong, kids? Absolutely correct. Absolutely. Perfect, kids. It's perfect answer. Now see, kids, another question. Just try to understand. This is really awesome question. If it is given like this, and they have given like this chloride, and they have given like this CH3, and they have done the reaction with C2H5ONA, and they're asking about product, major product. Now do let me know, kids, how many membered ring will be there in the major product? 5 membered ring? Hey, the major product will be of 5 membered ring or 6 membered ring. That you could let me know. Just to let me know, the major product will be having ring of 5 carbon or 6 carbon. Kids, everyone do let me know. The major product will be having ring of 5 or 6. I want to see your answer, kids. Everyone, do let me know. 6. So, kids, everyone is saying 6 membered, and examiner will give you big 0. Ask me why. Big 0, you will get failed. Everyone got failed. Ask me why. In the examination, in the question, there is no heading that this is SN2 reaction or SN1 reaction. You see, this is 2-degree alkyl halide. That's why I've told you that trick. 2-degree alkyl halide. And you know that 2-degree alkyl halide, and this is being strong nucleophile oblique base. So it will show SN2 as well as E2 reaction. And SN2 and E2 reaction takes place in single step. So this is an example of SN2E2 single step reaction. And single step reaction, no carbocation formation. Single step reaction, no carbocation formation. No carbocation formation means what? No carbocation formation means no ring expansion. No ring expansion. So kids, the correct answer will be definitely this one. This chloride is going from north upside. So the incoming nucleophile will attack from the back side. So inversion of configuration. So this is your product, kids. Everyone is able to understand this is your major product. Say thank you to me. Say thank you to your HSP Baba. You got saved because of me. And this is the way your HSP Baba is going to tell you each and everything. And that's why experience counts a lot. Your HSP Baba is having that much of experience, and that means a lot, and that holds a hell lot of weightage for giving you the best rank, kids. So everyone, you have to have knowledge of the reaction, whether the reaction is E2, SN2, SN1. Even if you're not able to understand that thing, you won't be able to give the answer. Now see kids, if the same question would have been asked like this, the same question is given like this. This is your question. Now this time, what they did, they have given the reagent like this, KOH aqueous. KOH aqueous. Aqueous means water is there. So, how many types of products will get formed and which is going to be the major? Now see, I'm writing all the products. You just let me know what is the major product. The first product I'm going to write like this. Take your time, kids. I'm not saying do in a hurry. Take your own time. So, which is your major product, kids? It's your litmus test. It's your litmus test. Yes, do let me know categorically. D, very good. Prathan, Akanksha, really kids, you're rocking. That your answer is absolutely correct. D. Now, kids, if the examiner by chance asking arrange the following products in decreasing order, then D will be maximum. After D, what should be the order? After D, C, after C, B, after B, A. This will be the order for formation of products. DCBA. Agreed or not? Agreed or not, kids? Yes, you got agreed. So, till now, you are able to understand each and everything, kids. Do let me know you have got it. Please hit the like buttons, kids. Smash the like buttons, everyone. Everyone, smash the like buttons. I want to see everyone. It's a humble request that everyone smash the like buttons. Make it 50. At least make it 50 if you're liking it. If you're liking it, if you're loving it, at least make 50. The like buttons should be smashed by you, kids. Now, I'm going to give you one question. See to it. Everyone try to understand it. Question is, in which reaction rearrangement will not take place? In which reaction rearrangement will not take place? See, options are given like this. A is C6H5 CH2 CH2 Cl. B is C6H5 CH3 CH CH3. In which reaction rearrangement will not take place? In presence of, it should be like that, in presence of KOH aqueous. No, Every time I'm giving you KOH aqueous, kids must be thinking, sir, every time KOH aqueous will come, I will let you know what other things can come. But stay tuned and remain at the last. It will take 30 minutes more so that I can tell you each and everything, even the minute things of this reaction. Now see kids, B and C option is like this. And D option is like this. Now, what's your answer, kids? It's a lovely question, really lovely question. Do let me know what's the answer. Yes, I'm waiting for your answer, kids. Do let me know. Yes, everyone, do let me know what's your answer. So, in which reaction rearrangement will not take place? So, definitely the answer is going to be this one, because in this the carbocation is already resonance stabilized. So in this reaction, no rearrangement. Very good, Vedha Janani, your answer is absolutely correct. C is the correct answer. Now see, if the reaction is given like this, no KOH is given. Simply they have given the reaction like this. See it, CH3, 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 Br, and water. Simply water is given over there. No KOH is given. Now, what do you think? What type of reaction will take place? So, definitely it is pure water. Pure water means polar protic solvent. So, in the first step, what do you think? In the first step, carbocation will be formed. Now, once the carbocation is formed, kids, this is slowest step, and this is going to be rate determining step. Carbocation has been formed. Now, what do you think in the second step? Who is going to attack on this carbocation? Kids, do let me know. In the second step, who is going to attack on this carbocation? Your answer will be that OH negative is going to attack. That is your answer. But kids, do remember OH negative is not there. Water is there, and water is always water. Water is not OH negative. Yes, water is H delta positive and OH delta negative, but water is not going to break. If you take number of molecules, then if you take millions of molecules, then out of those million of molecules, only one water is going to break. So water is water, and water will attack. Now see how the water will attack. Water is not OH negative. If water is OH negative, then NaOH and water, there will not be any difference. You can't find out any answer in between water and OH. Water is water, NaOH is OH, OH is OH. So now this oxygen is going to donate its one electron to this carbon. It will attack from the front side as well as it will attack from the back side. And here this is having 8 electrons and that is having just 6 electrons. So after donation of 1 electron, that will have 7 electron and this will have 7, and then they will do the sharing. Now after doing the sharing, see how it will look like. CH3, 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 O positive H2. Another intermediate has been formed. One intermediate, carbocation. Another intermediate's name is oxonium ion. So see, there is entry of oxonium ion. Gets oxonium ion. Till now, whatever the reactions I have shown, there only one intermediate was getting formed. in this reaction, two intermediates are getting formed. Now see, this is the slowest step. Why this was the slowest step, kids? This was slowest step because this was having 8 electrons. Why the reaction is taking place? This carbon is 2p and bromine is 4p. The overlapping was poor and this bond was weak bond. Weak bond. Why it is being weak bond? Because of poor overlapping. And that's why reaction has started taking place. Now, there was intermediate carbocation. This is oxonium ion, but oxygen is having 8 electrons. So, how 8 electrons are possible? Even though it has donated 1 electron, it has donated, and after donation, it has shared the same electron. Because of the sharing of same electron, the covalent bond is formed, and that's why it is having 8. So, this is fast. This is being fast step as compared to that. So the equilibrium will be more toward this side and less towards that side. But still, the oxygen is having positive charge, so not that much stable. Now, what is going to happen? This will lose its proton. Its proton, after losing proton, this oxygen is going to add electron. And this way, the reaction has taken place. And this is going to be the fastest step. Why? Fastest step, what is there? Now see, it is being fastest step because there is no charge. And why the reaction is going to take place? See kids, this is being 2p, carbon is being 2p, and this is being 2p. The bond of equality is always good. So this is the fastest step. So how many intermediates are formed? 3. And you must be thinking, sir, what is transition state? Transition states are the transition state is the step. This is your transition number 1. This is your transition number 2. And this is your transition number 3. Now graphically, if we are going to compare this reaction, if we want to see this reaction graphical representation, then graphically you will see it like this. This is, and this one. One side is the energy. Let me draw over here energy. And let us suppose this is progress of reaction. So this is the last one, kids. Now see, we have started from reactant. Let us suppose this is reactant's energy and we have to reach up to product. This is your product and this is being reactant. So see how the reaction is going to take place. It will move like this. The first step is like this and like this and like this. You can see, just compare. Whatever I taught you, you just see. This is reactant, that is product. The reaction is exothermic. How to find out the reaction is being exothermic? How will you get? Yes, that knowledge. You see, this is reactant and this is product's energy. The difference in between these two energy, that is delta H value. You can see clearly this is delta H. Are you getting my point, kids? This is the difference, that is being delta H. Negative, that is indicating exothermic reaction. Now this reaction has been started from here and completed over there. These valleys, you know, 2 mountains make 1 valley and 3 mountains will make 2 valleys. Whatever the number of mountains peak, that is what? That is transition state. 1, 2, 3. That is TS1, or you can say step, or you can say TS2 step and TS3. 3 transition states, and the 3 transition states, then they are proceeding with intermediate, this intermediate, this intermediate. You can see this is carbocation intermediate and this is oxonium ion intermediate. And you know very well, I've told you in the starting only which intermediate is more stable. Oxonium ion intermediate is more stable as compared to carbocation. Now kids, these many questions, what type of questions the examiner is going to ask? By simply seeing the graph, examiner will ask, just do let me know whether this reaction is SN1 reaction or SN2 reaction. Kids, examiner will ask whether this is the graph for SN1 reaction or SN2 reaction. What should be answer? This graph is for SN1 or SN2. Definitely, you have to give the answer that this graph is for SN1 reaction. How many transition states are there in this reaction? So definitely 3 transition states are there. This is moving this exothermic reaction. This exothermic reaction is with 3 transition states. So this thing is very much clear to all of you kids. Now 3 more likes I need, then it should be half century. I've told you each and everything about SN1 reaction, kids. How much you liked it, you are able to understand it or not. I have given all the examples, and in coming turn, I will tell you the applications of SN2 and SN1 reaction, whatever are required for your NEET rank, the best rank, the first rank, up to the first rank. And these examples will be mixed of the NCERT as well as other than NCERT, which is required for your NEET best rank. Kids, first of all, Soumya Deep Bhomik, hello, very good morning, or it's good afternoon. Good afternoon. Kids, at least hit the like button so that it can reach up to 50, and do let me know in the chat section that how much you're liking it as well as you are enjoying it, and you are getting the in-depth knowledge also. Liking is one thing, getting in-depth knowledge is another thing. You must have seen that I'm not skipping even a single thing, and I'm going into the in-depth knowledge of each and every chapter, kids. That's why this platform is the best platform to provide you the best rank, kids. Each and every teacher of this Conquer batch is really the best. Whether I talk about Ambika ma'am bio, physics or Capto sir, Shreyas sir, or I talk about our Wasim sir, or myself too. So only 3 likes I need. Make it 50 so that it can reach up to 50. If not, then it's okay. So each and everything I've told you, kids, just go through it. Try to keep it in your brain so that for further applications of SN2 and SN1, you can understand each and everything. If you're not keeping this thing in your brain, you won't be able to understand. You won't be able to do anything, kids. Okay. Bye to all of you. We'll meet you in coming next session. Right, kids? So for that, try to keep each and everything in your brain. Then I will let you know important points about the note for SN1 and SN2. Very, very important points. Right? Bye to all of you, kids. Bye. Bye. Bye.